It's a great pleasure to talk about my second love. My first love is physics, but the second love, which is women in science in general. And I have decided specifically to talk about women in physics and mathematics. So what is the plan of my talk? So I want to first give you two slides as to what was the origin of giving a colloquium on women in mathematics and physics. So I'll give you that. And then I would tell you first part of the talk, half-an-hour talk, is actually stories. I'll tell you stories, inspiring stories of women of mathematics and physics from the early history up to the middle of 20th century. But of course, it's not just a storytelling time. So the idea is, what do we learn from those stories? And then I want to go in the second half of my talk about what is the current situation. First and foremost, the question, have the issues changed? Secondly, what needs to be done? Because the answer is clear, issues have not changed too much. And then also, for most of you, since you wouldn't know, I would try to tell you what we are doing in India and what lessons have we learned. So let's see how this moves. So I was visiting actually the International Center for Theoretical Physics, where I'm an adjunct faculty, and I was spending some time there, and we were walking in the corridor. And for those friends of mine who are physicists, this picture is something that we all know, that this is the picture of the scientists who made the 20th century physics, who gave us everything that they discussed the physics that has given us everything that we are using in this room right now. And among this galaxy of the quantum physicists, there is this one person whom we all know, Madame Marie Curie. So in this galaxy, there was one woman, and this is in 1927. Next to it, in ICTP, there was another picture, and this was the picture of the conference that took place at the time of founding of the International Center for Theoretical Physics and their new building. So again, most of the people here, though I would not go through details, they were the giants of particle physics at that time. And then there was one woman at the back. So I kind of curiosity, I asked, is she a physicist? And then we found out, no, she was actually the administrative staff. Okay, so this is when we saw that there was a one woman, but she was not a physicist. Then a few days after that, in fact, I had to go to give some lectures at the house of the German Physical Society, which is near Frankfurt. And this house actually at the door has a really big poster of Emmy Noether honoring her. And again, for my physicist friends, I don't have to tell who she was. And for non-physicist friends, I hope in the story I will come around and tell you who she was. So she is at least my idol, okay? So, and here in the same hall on the side, since this was the special building of German Physical Society, this was, those of you who don't know German, this was the open inauguration ceremony in November 2003. And in this, there is only one woman. So I have given you two giant women in physics and mathematics from 1927, or in this case, she did her great work in 1911, and in 2003 or 2017 or 1960, there is no other woman in a significant, in some sort of, I mean, there is some crowd of significance when you say members of German Physical Society or people who are arrived at the High Energy Physics Conference at the foundation of ICTP. They are not women. No women are there. So clearly, number of women doing science is small, and that's not just in India, not just in Australia. It's a statement world over. Now, some people even start asking a question, is that necessarily bad? So what? Okay? And in fact, the answer is yes, it is certainly bad. It is certainly not the optimal use of humanity's intellectual potential. So you can think of any activity which is creative, diversity can only bring good to it. And it's not just women. It's diversity in terms of your racial backgrounds and everything that comes with it. So diversity can only be good, and this is one reason why number of women doing science being small is bad. Secondly, as far as India is concerned, the changing economic realities actually mean that the number of women who will participate in science is increasing. I don't know how you people feel, but by and large, when a particular profession is not economically really rewarding, very often men move out of it by and large, and then women come in there to fill the gap, because they can always fill the gap. That's not a problem. It's not that they don't lack they lack the abilities. So if that's going to happen, if I want to maintain the quality of science, it's important to make sure that this participation can be more efficient and more effective. And if there are any problems in that participation, they must be removed. Any hurdles, they must be removed. So this is something for the good of science. It's not for good of women. It's not charity to poor women, but it's something that science itself will suffer from this, and does suffer from this. So why am I spending so much time on saying this? It's because some very eminent gentlemen, one of them being US Supreme Court Chief Justice Roberts, in 2015, he went on record. He didn't say it for women, but he said it for the other minority. What unique perspective does a minority student bring to a physics class? So his statement really was that pursuit of science doesn't really need diversity. So this is Supreme Court Judge of the United States of America. The second one, which is also equally illustrious human being, Tim Hunt. He was Nobel Prize winner in 2011 for physiology and medicine. In fact, this is one subject where there have been large number of Nobel Prize winners among women, if at all. Okay, in other areas there are very few women, but this is one area where there are more women winning Nobel Prizes. But this Mr. Tim Hunt, in an interview that he gave in 2015, said, "Let me tell you about my trouble with girls. 3 things happen when they are in the lab. You fall in love with them, they fall in love with you, or when you criticize them, they cry." Must have been his experience, I cannot deny it. But I mean, the point is that when we have such illustrious people making these statements, it makes us realize that this is not the God-given truth that we all take it to be. That this issue needs to be discussed, and this issue, people need to be convinced of it. Now, why do I focus on mathematics and physics? Because I picked up 2 women, if you remember, one mathematician and one physicist. It is, in general, we are a long way from gender equity in science in general. In science and engineering, we are really a long way from gender equity. Numbers are small across all disciplines, but some are more unequal than others. And that is really true when you look at the faculty in mathematics, physics, and actually chemistry, the world over. Biology still, and biochemistry or computer science still do a bit better even today, if you just look at numbers. I mean, I have some numbers, and those of you who are interested, we can go through the numbers. So the numbers are even smaller in physics and math generally compared to all the other disciplines. Hence, I decided to focus on math and physics. Also, we have had, again, luminaries like Harvard President Larry Summers declaring that women lack capability in mathematical and physical sciences. In fact, there have been actually a lot of studies. People have been trying to study whether indeed there is a difference in the way women study physics and mathematics and men study mathematics and physics. I don't know if there is a difference, but if you ask me, there is no difference between mathematics or physics that is done by a man or a woman. I mean, there is no gender dependency. As much as there is a dependency between the physics I do and the physics he does, there will be difference between 2 human beings. The physics can be only different to that level. So everybody might have a different take on the thing, but it cannot be, there cannot be lack of ability. So in 2016, there was a very interesting Women's Day slogan which said, "Pledge for parity." So if we really want to fulfill such pledges, then all of us, scientists, both the natural scientists and social scientists, have to actually come together, and we have to discuss and try to look at this issue like a scientific problem. Because it is a problem, and we have to solve the problem. So one has to just look at it as really a problem that we need to address. And therefore, the discussions should not be restricted only to women, because after all, this is a problem that everybody has. They should not be restricted only to women's days, and they should certainly not be also restricted to women's conferences. So that's why I'm very heartened that today we are having a discussion on women in science when it's neither Women's Day, this is not a women's conference, and it's not restricted only to women. So I'm very happy on all these three accounts. I have collected information over the years from different sources. At present, I will just here give you, I have put in the slides few of the places where I collected information from for women in physics as well as women in mathematics. Then when I will tell you about things in India, actually it is some information which we had put together in the India report of the Women in Science and Technology in Asia. This was a report which was brought out by Asian Association of Academies of Science and Science Association in Asia. So all the science academies and science associations had come together, and we brought out this report a year and a half ago. And in that I put together Indian report of women scientists in India. So when I tell you information or numbers, they are essentially something that we have put together in this report. And I will sometimes also refer to some thoughts on analysis and possible solutions that I expressed in an editorial in Indian version of our multidisciplinary journal called Current Science. So I begin, when I told you I begin from the early history, I begin from Greek times. So this is actually the first woman mathematician, known woman mathematician about whom records are available. And she was daughter of Theon, who was the last known member of the Library of Alexandria. As we know, in those days, libraries were the big things, and a librarian was an extremely important position. I mean, it was the custodian, a librarian was the custodian of knowledge. And she actually translated and wrote commentaries of classical mathematical works and lectured to students. Unfortunately, she was killed in the unrest in Alexandria between the Greek, beginning of the Roman times. But she was also a philosopher, and there is a lot of record what she had done. And India, though not, because here I have given you a person who lived in few hundred BC. The Indian example that I will give you is not from BC, but the one example that we have been able to kind of track is that there might have been an Indian woman mathematician. In 12th century India was actually one of the big working grounds. Mathematics in 12th century India was indeed very highly advanced, and in fact there are treatises which were written at that time in arithmetic which are even today sitting in, for example, Courant Library and stuff like that, where these are being studied. So these mathematicians were mathematicians of very high ability and repute. One of them was Bhaskara too, and as I said, his handwritten manuscript is actually in Courant Institute, and this is called Leelavathi. So in this book, he actually writes most of the problems. He gives lots of arithmetic problems, and all the problems are addressed to a girl called Leelavathi. So for example, it says, this is a translation, fawn-eyed child Leelavathi, tell me how much is the number resulting from 135 multiplied by 12 if you understand multiplication by separate parts and by separate digits. This is really classic arithmetic problem. And tell me, beautiful one, how much is that product divided by the same multiplier. Now this legend has that she was his daughter. Legend also has that she was widowed very early in her life, and legend has that he taught her mathematics. We don't know any proofs apart from this, that the book is actually called Leelavathi Bhaskaracharya Samvada, which means conversations of Leelavathi and Bhaskaracharya. And the fact that Bhaskara lived, there are no questions. So we all believe that this is one of the evidences of early woman Indian mathematician. This is actually just to show you the handwritten manuscript, and you can see this is the size. Okay? And for example, this is a very classic trigonometrical problem. There is this bird sitting on the top. The bird wants to catch the snake. the snake is moving at a certain speed, the bird is moving at a certain speed, and the height of the pole is given, and she is asked to calculate when will the bird catch the snake, or will the bird not catch the snake. And this is a simple problem of a trigonometry, but this is the problem. So these were this and many such problems exist in this book. So now from 12th century, I come immediately to Europe in 17th century. I picked her up because she is the first woman PhD in 1678 from University of Padua, which is of course a very venerated old university. And her biography has been written by a lady called Margaret Alec. And what is very interesting is that she actually wanted to study theology because she was born up in a family of theologians. And she was told that women can't study theology. If you want, you study mathematics. So the point is, whatever is considered as the supermost branch of knowledge is something that women are not fit for. That is the underlying, and there, again this exists, records exist for, this statement is, I have studied this from this book of Margaret Alec. Then we come in 18th century, actually there were many more women, and I have found records about these 6 women, and the ones I have written, whose names I have written in red, I will talk a few minutes each about. But I would like you to see that these are all, at least most, all these names are here European or British. At this point in this list, we don't have any American name, but this is also because the American War of Independence also perhaps hadn't happened by this time. Okay, all right. So I will talk about Sophie German. I think it's really a story. When I read it for the first time, I was really completely surprised. I didn't know this story. So Sophie German actually was young at the time of French Revolution. And because of the French Revolution, she was sort of confined to the house, and her father was a scientist. So she read lots of books which he had in the library. And when she read that book, she was completely taken over by the story of Aristotle, who was killed in a war but didn't realize it because he was thinking about science. So she actually wrote in a letter to somebody how great it must be to be lost in scientific thoughts that you don't even realize. I mean, he was her hero. But this woman was told that she cannot study mathematics. Middle class girls should not study mathematics and science because it's not proper. So much so that these people actually took away her candles so that she will not study. And then first they removed the candles from her bedroom. Then she decided that she will come out and sit in the dining room. There was a candle there, but then there were no blankets and no heat. So sometimes she would work at night on the table, and the ink would freeze. So finally they gave up and then said, okay, if you want to study so desperately, please do study. But again, that means that she lost a lot of time and had no real proper training. She actually attended the École Polytechnique at that time, was just founded. So we are talking of really early times. So she used a pen name of a friend to communicate with Lagrange and Gauss, who were the leading mathematicians at that time. And she actually ended up doing some very important work on theory of elasticity and the famous Fermat's last theorem. She actually had one of the first inroads in the Fermat's last theorem. There are these things called German numbers. Okay? And she was the first woman to win a prize from the French Academy. But the fact that she wasn't allowed really training in the beginning, she suffered from that all the time. Because since she didn't have a formal training, for example, this thing for which she won the award, she submitted this work 3 times for competition. And every time they said, your thesis is correct, but this needs to be worked out. And at 3rd time around, everybody said yes, because she lacked the methodology. So here was a brilliant woman and a brilliant mathematical mind. And you don't have to take my words for it. There is a quote from Gauss. She had been communicating with Gauss as a man. And then when she went and visited him, he realized for the first time that, my God, this is a woman. So he said, how can I describe my astonishment and admiration on seeing my esteemed correspondence, M. Leblanc, metamorphosed into this celebrated person? And he actually tried to get her honorary degree from university where he was at that time, but it didn't work. And but this is the point, that she proved to the world that even a woman can accomplish something worthwhile in the most rigorous and abstract of the sciences, and for that reason would well have deserved an honorary degree. So this is the first example of a woman mathematician, and I don't have to tell you what lessons we take from it. The lessons are obvious. Then the other one, the next one in the line, is Mary Somerville. She was drawn to mathematics by equations appearing in a fashion magazine. She looked at it, and there were some, she basically worked on numbers, okay? And then she started studying science, but the father initially was opposing it. She got married, but her first husband died, and the second husband was supportive. So he said, okay, you want to study mathematics? He used to actually bring books from the library for her. And she had a lot of support from Charles Babbage and Herschel, who were the leading scientists at that time. In fact, she translated many books by Laplace and made many commentaries, and her work and her translations inspired the search for Neptune. And so discovery of Neptune, you can say, was indirectly attributed to her. She even became the first honorary member of the Royal Astronomical Society. And more importantly, she was the first one who actually gave the definition of the process of science. So in fact, I mean, there were so very few scientists, but it was a woman scientist who actually gave the definition of what the process of science is all about. So very impressive woman. And today there are many colleges in Cambridge, one college in Cambridge, I think, which is named after her, which is Somerville College. Then there is this really famous, everybody knows the name of the astronomer Herschel. I'm sure everybody around here would know his name. But nobody knows that the sister of the royal astronomer Herschel actually came from Germany to England to help her brother keep house. But then as royal astronomer, Herschel asked the king to pay his assistant. So she became the first paid woman scientist. And she was really a scientist in her own right. She got a gold medal of Royal Astronomical Society, and she searched a lot of nebulae clusters and comets. A lot of these in the list are attributed to her. So first she started by helping him to polish the mirrors and stuff like that. And she ended up being an astronomer in her own right. And she used to say that she was the Cinderella of the family. But again, the fact was that Herschel did not notice it and decided that this was a person who needs to be supported. What I want to show you is that there is this recurrent theme that almost each of these women, you will see, have had some mentor or the other. I mean, they have had their enormous energy, that of course goes without saying, and knowledge and intelligence. As we come to 19th and 20th century, numbers start increasing, luckily. So here I'm going to talk about only maybe 3 or 4 women. The remaining, I have their stories, but I think I will skip those stories and come back to it if we are left with time, because it's interesting to talk about them, but I want to also go and really discuss the issues. So I will talk about these 3 women. One was Ada Lovelace, who developed the first algorithm. So the fact that we write computer programs today is really, she was the first person who wrote the first algorithm which worked on Babbage's first computing machine. So I mean, and she died quite young, as we will see. Yeah, you can see it here. She was not very old when she died. Then there is another one which is really a glittering one, Sophie Kovalevsky. She was a mathematician. I will tell you about her. I would want you to remember these 2 names because I will come back to these 2 one of them in my later story. She was Agnes Scott was a British, but she then moved over to USA. So these are the first 2 women in USA that I could think of who were, and I have clubbed astronomy, astrophysics with physics. So therefore there is this Maria Mitchell. So Marie Curie, of course, legendary Marie Curie and Emmy Noether, about whom I will talk. And then Lisa Meitner, C.S. Wu, and Maria Goeppert-Mayer. Maria Goeppert-Mayer is only the 2nd Nobel Prize winner in physics along with Marie Curie. And C.S. Wu and Lisa Meitner are more well known for the fact that they missed the Nobel Prize, which should have been theirs. So that's why I have put these names here, and I will want to choose some of the stories to tell you a little bit about. And last but not the least, along with these famous names that I am giving you, as we come in the 20th century, there is a large number of women about whom we don't even know. And one of them recently came out as, I'm sure many of you are familiar with the film called Hidden Figures, and these are the 3 hidden figures, Dorothy Vaughan, Katherine Johnson, and Mary Jackson, Mary Jackson was the first woman black engineer, and Katherine Johnson was completely in charge of calculating the orbits of the first astronomers who went into space, John Shepard, as well as the person who went to the moon, Glenn, I think Senator Glenn, yeah, Glenn. And this one here is again an extremely interesting woman. Her name is Mary, I cannot pronounce this name, but she worked with Fermi, Ulam, and Pasta and proved one of the most impressive, gave a proof of one of the most impressive theorems that even today is being studied. And her role in this was not known for a long time. She wrote the computer codes to do that. And it's not just writing computer codes. I mean, those are very special computer codes. Same here, she was the first computer programmer with NASA, and she was the first woman African-American engineer with NASA. So now we see after this, they started coming a bit thick and a bit thicker. And I cannot end my story and the gallery without telling you about the first woman who ever to win Fields Medal, so which is the analog of Nobel Prize in physics. In mathematics is the Fields Medal, and she was the first Fields medalist, woman Fields medalist. Unfortunately, she died very young, and she came from Iran. So again, it's quite amusing that when I give you the names of these women, most of them have come from societies which are well known to be male dominated. Almost most of them, if you look at them. And this is again, it's true even as late as 2007. And here, she received one prize, first woman to receive really a high profile mathematics prize was Emmy Noether. And now, after so many years, it was first field medalist Mariam Mirzakhani. So this is a big story. This is a big travel from the first Greek mathematician Hippolyta to the final Mariam Mirzakhani. So that means that throughout the ages, we have had these women who are exemplary, who are great, who have achieved something really fantastic, but they are small in numbers. So now let me tell you a little bit about the 3 stories of the few women that I wanted to choose. And then, yeah, because I want to be finished with this part of the talk in another 5 minutes. So Ada Lovelace, as I already told you, she was actually a daughter of Lord Byron. She was tutored at home by none other than Mary Somerville. So the advantage of having elderly women is here obvious. And she also had a lot of interaction with Babbage, who encouraged her to write an article, commentary on an article by somebody else from Turin on the analytical machines, which was proposed by Babbage. So this is the first computer that Babbage actually proposed. And she was the person who wrote the first algorithm, because this comment that she wrote was actually that algorithm. She, as I said, she didn't live very long, but she is the first computer scientist, if you wish. Then comes Nia Kovalevsky. Her story is absolutely inspiring. She was in Russia. She studied at home. She was taught only at home. She came from a big, rich family. And then she wanted to study mathematics. So she left, got married to a cousin so that they can both go to Europe. And it was a marriage of convenience, which unfortunately didn't last, which on personal fronts brought her a lot of aches and pain. But on the scientific front, she went on to work with Weierstrass, who was one of the big mathematicians of the time. And she became the first woman professor in mathematics, that is the first woman professor in Uppsala. and she won a very prestigious prize called, I cannot pronounce French, but Prix Baudin, and she had an extremely unhappy and lonely personal life. She writes, "I'm as miserable as a dog. No, I hope for their sake the dogs cannot be as unhappy as human creatures, especially as women." And you know on which day she wrote this? She wrote it on the day she won this award. So that tells the struggles that this woman had to go through to do the beautiful mathematics that she gave. Okay? So, and there are still unfair statements in somewhere in the corridors that the work was actually Weierstrass, but not hers. Though why Mr. Weierstrass would want her and for work which he has done to be given to somebody else is something that would goes beyond me. Then of course there is Marie Curie, and she was a scientist par excellence, man or woman. I mean, there is no question here. And she actually said this, that life is not very easy for any of us. So this is the comment of the woman who has gone on to win 2 Nobel Prizes. We must believe that we are gifted for something and that must be attained. But this obviously says and describes that there were a whole lot of obstacles in her path. And in fact, she got her position only after accidental death of Pierre Curie. But it is still it goes to the credit of Pierre Curie, who himself was a great scientist, that he never failed to emphasize her contribution. Society would have been far too happy at that time to say that it's all Pierre Curie's work and she just did the chemistry. But that he actually went on record very often saying that that was not the case. Then comes the story of Emmy Noether, which I really want to tell you, because today we are celebrating this year 130 years of a famous theorem called Noether's theorem. And for physicists in the crowd, we know that theoretical physics lives by Noether's theorem. I mean, there are none of the developments in particle physics that we see today would have happened. The mathematical formulation would not have been possible if Emmy Noether hadn't proved an extremely important theorem in 1911, where she was invited by Einstein and Hilbert, 2 big giants, to visit Göttingen so that she can help them with her knowledge of theory of invariance to understand some problems in general theory of relativity which they were not able to tackle. And can you believe that at this time, this lady did not have a permanent position anywhere. First, she could not even get a degree because women were not allowed to the university. So in a few years, somewhere in the course of her doing PhD, women started being allowed. So she was studying at home because her father was a mathematician. So she is the first woman to get a PhD degree from University of Erlangen. She did not get a paid teaching job for 7 long years. And as I said, it is in this time that she came to Göttingen and proved these earth-shaking theorems. And not just that, went on to found fundamental branches of mathematics. So there are actually conferences on things that Noether started. They are called Noether's rings and so on and so forth. She founded the many important subjects in mathematics. And this woman gave a talk at the International Mathematical Congress when she got that award that I just now told you, the Teubner Prize, when she did not have a permanent position. Then came, of course, the World War. And at that time, being a Jew, she had to leave Germany. In spite of the fact that she had full support of Einstein, the only job she could get was given by our friend Charles Agnes Scott. Remember, I told you she was a mathematician, the first mathematicians in the US. She founded this women's college, mathematics department in this full women's college, Brandmauer College. And she gave found funds for her to come to USA. And she used to travel to Princeton once a week to give lectures on projective geometry, which used to be attended by none other than Einstein. But Princeton University couldn't find it in their heart to give her a job. In fact, she went on record being extremely critical of Princeton University professors. She was very happy with students and she used to teach them. She was immensely successful as a researcher, as a teacher. Her students and collaborators were called Noether boys and Noether girls. So, and she used to be called in German der Noether. So, der is a German pronoun for masculine, indication of masculine. So, she used to be called der Noether. And in fact, there was a big exhibition in New York about men in mathematics, and there was all men and one Emmy Noether, whose picture was put in that gallery. So, the world of mathematics appreciated and understood Emmy Noether's contribution from day zero. But the social world was not even ready to accept to give her a professorship for this somebody like this who had just such legendary contributions to mathematics. I mean, I can go on with this for many long time. So, here I would sort of make a small digression to tell you that since this was 130 years of Emmy Noether, this theorem, what we did in India is that we brought out a magazine, we bring out a quarterly called Physics News from Indian Physics Association, and this time we decided that the March issue will contain articles only by women. And the cover article was on, of course, Emmy Noether and her theorem. In fact, we went this year so far that not just the Physics News, but also there is an education magazine we bring out called Resonance, as well as our interdisciplinary magazine called Current Science. And in March issue, all the articles were by women. And we just compared that in the earlier 2 years in Physics News, there was not a single article by a woman. And Physics News articles are usually invited articles. Okay. So, this already I begin to tell you a bit about stories in India anyhow. So, okay, now these next stories I think I will have to cut, but I will not cut this one because Lisa Meitner was again an Austrian who couldn't get a degree initially because women were not allowed to go to university in Vienna. But nobody, they didn't tell her that she was not allowed to do physics. So, she obviously did some fantastic physics with Frisch, who was her nephew, and Hahn, who was a lifelong collaborator. And for again those of you who are not physicists, she was the one who worked out the physics of the process which happens in nuclear fission and calculated the energy released when the fission happens. And in fact, there is enough proof that she had the ideas because she had written things on a postcard. She had to flee again Germany because she was Jew, and she had written on a postcard some ideas in a letter written to Hahn, giving him ideas what kind of experiment he should do to confirm, test her calculation. And in spite of all that, the Nobel Prize for nuclear fission actually went only to Hahn and not to her. And many people believe that two things, Jewish religion and gender discrimination, both might have had something to do. And she lived till very long, so almost to be 90, and she used to be reasonably unhappy about this. And I must tell you that as a student, when I studied nuclear fission, even nobody taught me that this was a very important role played by this lady. We all thought it was Hahn because Hahn got the Nobel Prize. So I learned about it only when I actually looked at the subject as a woman physicist. Even Emmy Noether, and I have not realized she was a woman. Noether's theorem, I mean, we lived by it, we died by it. After a long time, somewhere along the line, I realized, oh my God, she's a woman, and she's the only woman in that galaxy of mathematicians of that age. So this is just to give you all these inspiring stories. Now I'm going to skip my telling stories, but I'm going to bring a last story which is very interesting. It's an American ecologist, and she is really somebody called Pillu. She was mother of mathematical ecology. I mean, normally subjects like biology don't have too much mathematics in them. But analysis of behavioral trends of colonies of people and so on, or animals, one needed to develop a mathematical framework, and she actually developed that framework, which some of you will know. Today it goes by the name of systems biology. So she is the founder of systems biology. And she did her PhD work at home by herself and submitted it through distance education to University of London and got a PhD. So she was born in 1924 and got her first university job in 1968. But she lived quite long and she got a lot of accolade. People really appreciated, and she was a wonderful teacher. She got an Eminent Ecologist Award in 1986, quite a bit later. 68, 86. But what I want to show you this year is for one particular reason. In early part of her life, when she has just got her PhD and moved to Canada, she wrote a paper showing that somebody called Robert MacArthur, an extremely eminent ecologist who got this eminent ecologist award a few years before Pillu, so obviously he was also up there somewhere, and at that time he was like the ecologist, and she wrote a paper showing that he was wrong, and that paper was entitled Correction to the MacArthur Formula for Abundance of Species. What I want to show you is a paper written in a journal called Ecology by Robert MacArthur. Please look at the title. Note on Mrs. Pillu's comments. She is Mrs. Pillu. Huh? She is not doctor. Even worse than that. I am happy to agree with Mrs. Pillu's formula is literally correct and ours only in approximation. So she was actually pointing out something very important, that in statistics, whether you take averages before taking sums, or whether you take average of the mean of the sum or sum of the mean. I mean, these are statistically two very different operations. As it happened, it hadn't made any difference for that particular problem. So it was a very important problem that she had pointed out, and this gentleman goes and says, let us hope these comments do not draw additional attention to what is now an absolute approach to community ecology. Because as it happened, he had more mistakes with this, and therefore that whole approach had to be abandoned. But I cannot imagine, I mean, I don't think that this arrogance would have been there if the author was not Mrs. Pillu and was some doctor, somebody or the other of another gender. So this is the story of somebody in 1968. So what do we learn? Now we begin with our lessons. I hope it's clear that all of these women were supremely confident of the science. They were supremely passionate about their science, and they all enjoyed their science to an ultimate degree. But what was important is that almost all of them, excepting maybe somebody like Pillu, had a mentor. Either that mentor was family, like husband in the case of Somerville, or it was other scientists like Babbage, or other women scientists like Agnes Scott and Somerville. So in each case, you can, for example, so for Emmy Noether, there were people like Einstein, people like Hilbert. For example, Hilbert actually is gone on record when he was trying to get her a permanent job in Göttingen. So he told them that men, we are not talking of a public bathhouse, but we are talking of a university, so the gender of the person is irrelevant. He actually, this is a quote, I mean, I can, so she got enormous support. So all of them got attitude of the community. So you got this support. The academia always bowed down to the supreme achievements of these supreme women, but there were lots of sociological problems. For example, I didn't tell you, but Maria Gopatmeyer, who got only the second woman to receive a Nobel Prize, got her permanent job 2 years before she got the Nobel Prize. And the reason was given is that her husband was also a very eminent physicist, and they said we can't give a husband and wife job at the same university. I have not done a study, but I would really like to collect data. How many times brothers or fathers and sons were denied a job, quoting the rule of nepotism? I am not aware of any. So, and that happens even today, by the way. So, the attitude of the community was really not helpful. And for example, we have Mr. Robert MacArthur making such caustic comments against a person who had just started coming into science. I mean, she was very young at that time. Not young age-wise, but young science-wise. So this is, so now we see that the sociological biases definitely lead to illogical obstacles. Like the first Italian mathematician was told that she cannot study theology. That's an illogical obstacle. And there will be, I don't even know how many such obstacles and how many such women are lost to the cause of science because of such obstacles. So academic achievements were appreciated, but there seemed definitely a bias in the recognition and the award coming women's way. And last but not the least, is quite a lot of these famous women either remained single, chose to remain single, or they were married to fellow scientists. There were very few among these, except exception of Mary Somerville, who was married to a non-scientist and who actually helped her along. So these are all the things which, if I take it out now and start talking today and look at the distribution of women doing science today, you will find exactly the same stories. So this has not changed. Even though the stories, these women are towering women, and what I'm going to talk about now are perhaps not such towering women scientists, but the point is you don't need to be that towering person. You don't, every man physicist is not Einstein, but they do science, they do physics, they do important contributions. So we should not be expecting every woman to be Marie Curie or Dorothy Hodgkins or Mary Somerville. So that is the thing that therefore in modern day India, for example, I looked at women physicists from the period of 1930 onwards, and again I took 3 examples because of the point they will make, is that there is one Professor Anamani. She was the head of meteorology, first head of the independent India's first meteorology institute. Dr. Purnima Sinha. I will go about these 3 women in the next few, and this 4th, she's a mathematician. I'm going to tell you about these 4 women because there is something very interesting to see how common things are, as long as, and yet how different they are. And I am taking this from Stories of India that we brought out. We brought out a book called Leelavathi's Daughters, which were stories of women scientists who trained and worked in the independent India. And in fact, actually, I have got with me copies of this book. I forgot to bring them here, but I'm happy to pass them on to anybody who would be interested. So we call that book, and this was important because we said that you need to know, you don't need to be a Marie Curie to be a scientist. You can be a Bimla Bhutti. You can be Anamani. You can be a person who lives in modern India, and you can still be a scientist. This was our hope in this. So what were the stories of these women? I will come back to this. Yeah. So these stories are taken from this book, okay? So this is basically nothing much. Anyway, I can show you. This is the cover of the book, and you will realize that what I have brought on the cover is the photograph of those verses from Bhaskaracharya Leelavathi Samvada. You can see them here much more clearly. Okay? So this book is something we brought out about 10 years back, and these are stories which have been told by women scientists. So Anamani worked with India's only Nobel Prize winner in physics, Sir C.V. Raman. Purnima Sinha worked with equally illustrious person, Satyendranath Bose, of the Bose-Einstein statistics. And both these women actually were very successful. She was a deputy director of the meteorological department and retired as a director general of observatories in Delhi, extremely important activity. Purnima Sinha worked in Central Glass and Ceramic Research Institute, and she has, all her daughters and nieces are all successful physicists. There are four or five of them. I know 3 of them very well personally, and they're all extremely successful physicists. So somewhere family makes a difference. Then this is a very interesting story. This is much closer to our times. She got her PhD in 1965. She is a fellow of all the academies. She is a mathematician. And what I want to show you is this here. When she was young, she couldn't go and study mathematics as a girl. So she used to dress up as a boy and went and studied mathematics. So India has also had its shares of women who wanted to do. So what is the Indian story today? I've told you these stories which are sort of special. The thing is that if you look at it, in academia, nobody thinks that women cannot study mathematics or physics. So in India, nobody thinks that women are incapable of any kind of intellectual attainment. Not just that, many of the university prize winners in science are usually women, in fact. But so we don't have our Larry Summers. Okay, that much is true. But we are still not inundated with women doing science. So if you ask what is the fraction of women scientists, again I can show you some data later on, in physics and mathematics, it's not more than 5 to 7% in the elite institutes. I was the first woman professor in the University of Bombay in physics. I was the first woman fellow of the Indian National Science Academy in physical sciences. Professor Bimla Bhuti was the first woman fellow in Indian Academy of Sciences. So, in spite of the fact that we have large number, we have about 25% women among the PhDs in physics, which is a big fraction. But when it comes to faculty, research workers, we have very few women. So the presence of women students in schools and colleges is very high. Their level of achievements is high. But the participation of women in research is extremely low, and presence in high positions in academics is even lower. We have an iconic institute called Indian Statistical Institute, and which has got its first woman director now in 88 years of its existence. There are a large number of women in that institute who are doing excellent statistics, but the first director has come only now, last year. So the serious leakages are there in India in the pipeline from college to university to scientific careers. I can give you numbers. So again, obvious conclusion is that in India, the participation of women in studying science, or for that matter teaching science at all levels, in schools, colleges, university, you have science teachers, all women. But if you ask in the end, how many of them are doing research, how many are directing research, how many of them have their own program of research, then you find there are very few. So we have no shortage of women studying science, we have no shortage of women teaching science, but we do have a shortage of women doing science, and as we go up in the positions, decision-making positions, the numbers dwindle almost exponentially. I mean, exponentially the other way around, height in the position minus. So in India, actually, with the increased spending on science, that has been advocated and envisaged, one of the issues is human resource development, I think, which is true everywhere. And in India, our problem is there is human resource development, but more importantly, deployment of the trained human resource is India's big issue. We are losing out the trained scientific woman power. So in fact, on behalf of the academy, I will come back. I thought that's the next slide. I'll come back to this deployment issue in a few minutes. But some things are better. But for example, first woman elected to the Royal Society, which was founded in 1660, was in 1945. First woman selected in the French Academy of Sciences was in 1979. Madame Marie Curie was not elected to the Academy of Sciences in France. Getting 2 Nobel Prizes was not enough to be an academician. Whereas in India, Janaki Amal, whose photograph I showed you, was actually the founding fellow of the Indian Academy of Sciences in 1934. So we were good in some sense, but then we lost it also along the way. The first woman fellow in the physics division was in 1975 for one academy, and in 1992 for another academy. Now since 1992, things have started changing because people have started talking. So this was Janaki Amal. So she actually remained single, and she was the director of our first geological survey. This is Bimla Bhuti, as I told you. She worked with Chandrasekhar, who was the astrophysics Nobel Prize winner. So I have picked up women, all of whom who worked with extremely celebrated men. One physics Nobel Prize winner, our astrophysics Nobel Prize winner, and discoverer of both statistics. So you cannot think of more illustrious physicists to work with, and all of these guys actually had women students, and they all did extremely well. But again, none of them ever ended up being directors anywhere. So in 2004, Indian Academy of Sciences actually constituted a panel called Women in Science, and I was the founding chair of the panel. That has been going on. Now I'm no longer the chair. And the Indian National Science Academy gave us funds, and we brought out the first report of studying science career for Indian women, access to science career for Indian women. So this was the first time. So the statements that I made to you, that we have shortage in women in science careers, they all come from these studies that we had. All right. So now, what do we do? What we are doing is various things. First thing we said that since our biggest problem was the pipeline leak at the top after PhD, so we decided that we will do a survey and ask those women who leave, why did they leave? So actually it was very difficult to locate them. Of course, I mean, you know, they have finished their PhD, they are gone. And we did a lot of effort, and we created a database of about 1800 women, out of which 200 were women who had left science. So of course, to a comparative study, we had women who have done PhD, who are in research, women who have done PhD but are in non-scientific jobs, women who have done PhD but who are in teaching jobs, and these women who have left science. Plus we had men in the same category, but only 50-50 in numbers. And then we did a survey, and we learned quite a few lessons. Again, I have brought copies of the survey, and I will be happy to share them with people here. And we learned something very interesting there. I'm not going to show you the plots, but the point was that we asked everybody a question, what is your perception? Why do women leave? So all the men and all the women who had not left said that the single most reason is women choose to leave because of family responsibilities. They said they choose to leave. Whereas the 200, out of the 200, some of the women who agreed to be interviewed, they said they did not choose to leave. They left because they didn't find supportive attitudes in society and at the institutional levels such that they can combine their home and research and balance it together. So that's a very different perception. As you can see, somebody says you choose to leave, then it's your issue. But if you are with this imperceptible pressure of non-availability of support structures, if you are forced to leave, that is something, that's a discrimination. It's an invisible discrimination, but it's a very real discrimination. So we really, and we actually found a lot of other things. So in general, there are two-pronged course of action that's going on in India. One is societal and mindset, which you need to change. That's what we learned. And a second is how much of it can be helped by policies. So I already told you what we did in terms of what academicians can do. I told you about this book. There is a similar book which was brought out by Department of Science and Technology, which was called Balancing Act, and the aim was to give role models. So stories of women who have been successful in modern day India. In addition to that, we did this survey that I told you. And then in Leelavathi's daughters, we looked at what was helped them to become successful. And these are the common things. Parental or parental in-law support, role models in schools and colleges, usually female, help during early career, especially during the days when you have to raise children, mentors who are usually senior colleagues, and one last most important one, that chance. Many of them said, but for this, if it hadn't worked this way, I wouldn't have continued. And the way I see it, and the way most of us who are working towards equity see, is that we need to find a course of action which will work towards retention and which will remove chance from this list. That would be the aim. Okay? The aim really would be at the end of the day when we not to be called women scientists, but we are scientists who just happen to be women, where the gender becomes immaterial. But funnily enough, to go to the stage where gender becomes immaterial, we have to go through a long period where we have to be very aware of the gender difference and where we have to build a mindset. And right now, most of the efforts that are going on from the size of the academics is really on this level. But now you ask the question, what kind of policies can I bring out such that this can be brought about? One is mental changes. So this is something that you need to spread the word, that it is not impossible to maintain a career and family balance. This needs to spread to the parents, the family, and the colleagues, so that that becomes an acceptable course of action, so that people don't say, why are you trying to continue? No, one shouldn't have to hear that. Because if you hear that from a mentor at the age of 26, 27, you say, maybe I'm making a mistake. You know, this is a very vulnerable stage at your career none of us are very sure at the age of 28 that we are going to be successful in science. We are taking our first baby steps. And at that time, what we need is a lot of support, and therefore, we need to sensitize the parents, the society, and even sometimes co-students. You need to address the gender imbalance from an early page, and this is the policy change. These are social changes. And policy change, where we are trying to have special programs for young girls in prestigious programs like Science Olympiads, or our famous institutions called Indian Institute of Technology have very few women. So we have now special programs such that we can increase their participation in these institutions. So this is a program which will be somewhat of a policy program. So major policy changes are happening in India. There are different names under which they come. Some of them are quite good. In fact, they provide a path to come back to science after people have taken a break. And that has worked reasonably well. But my worry is that people think that once they have provided that, the job is over. Now we will get gender equity. Somehow God will agree and we will get gender equity. But what is required is to set up processes in place such that those breaks are not necessary or those breaks are minimized. And that's exactly what all the women who were successful said. We don't want to take a break. We want things, mechanisms that will help us go towards it. So in fact, by and large, you need to provide a level playing field for women, and you need to think of, put policies in place, put mechanisms in place such that that will happen. I want to make a sort of a side comment that it's always a bit of a myth when you say excellence always works. And the reason I'm telling you this is that there is a CNRS study where they shows, and I can show you a plot, performance index for women in the same position as man is about 1.5 to factor 2 higher. There is a Swedish study which says the same, which means that for a woman to achieve the same level, if you measure her performance index in terms of talks given, in terms of grants earned, in terms of students directed, whatever you want to say, you will find that that performance index, and this is not my work, this is the work of these people, that the performance index for associate professor or for professor in a given class is always higher for women than men in almost a wide cross of institutions. So awareness of this in the community is needed. This goes more in the mindset. So here are the policies. Simple, sounds simple. A good creche on every campus. We don't have that. Then high priority to young couples for on-campus housing. Usually the on-campus housing is given to people who are seniors. But what you want is really those who can go in the middle of the night to the lab or work after dinner in the lab. So you want on-campus housing. You want proactive hiring policies for helping couples manage dual careers. You do not want to give them the job in the same institute, but help them. Be positive about it, rather than look upon it as a negative point that it is a couple which is looking for a job. And actually, including improving work climate is also an equally important point. There are harassment issues, and we tend to most of the time forget the elephant in the house. So all these are policy things. And our department, we have suggested this to the Department of Science and Technology, and some of these have been accepted. Some of these are still to be put in place. There is a committee for women in science of the Department of Science and Technology, of which I happen to be a member, and we are trying to get the government to implement these simple changes. But last but not the least, what I really want to, at some stage, my own dream is that we will have gender audit, which is partly a little bit like SAGE for institutions, where you ask the institutes to take the responsibility of the gender imbalance in each institute, in each university. And this not to be controlled from the central government by making a rule that 50% of the women should, the staff should be women, because numbers are only a symptom. And making equal numbers will never solve the problem if you do not address the issues that cause that inequity, if you do not address the attitudes that cause that inequity. So therefore, this gender audit is something that is a favorite of mine, which we don't have. So this is what I already said, that the lack of numerical representation is a symptom, and achieving numerical targets will not mean problems are solved. It is necessary, but it is not sufficient. And even more importantly, I don't believe in 50% or 40% or quoting such numbers. Each discipline, each department will have a different criterion. Because if I don't have in the pool trained women who are 50%, how are you going to have 50% in the faculty? So each department, each institution can actually set its realistic targets. And that is my own hope, that someday, depending on each discipline, you can say that we will have different targets and we'll try to meet them. But so this is my last word, that let me just assert the following, that consideration of how to increase the tribe need to be in the minds of powers that be, and not just in the minds of people like me who are being affected. So involve the men. I mean, that's my, that's sort of my short policy, that you have to involve the men. And particularly, I must say that in Australia, I was very pleased to see how many men are really involved in the initiatives like SAGE, which is extremely good. So you need to have this, it is not, and it should not be just restricted to the International Day for Women and Girls in Science, or Science Day, or International Women's Day. Then and only then can we come up with solutions which will work for us in India. And then a day will come when we will just speak of scientists, engineers, and not their gender. The way to achieve this, surprisingly, goes to the path of being aware of the gender and the gender gap for a while. Thank you.
It's very interesting because sometimes the perception is that there's a cultural imperative. What you've said is very similar to what's happening here, that the leaky pipeline is the major problem. And in physical sciences, you just have to spend a little time looking at the data. It's very significant. And of course, you just have to look at a school like mine just to see how it plays out in practice. Many people within the discipline are advocating cultural change. That sounds quite a soft thing to do, but in fact, it's actually quite a hard thing.
I think that is that's the most difficult one, but that is the most essential one, is the point that I'm trying to make, actually. I mean, because I'll give you another example, that for example, in medical colleges, 50% of the women are indeed, 50% of the students are indeed women. And in medical sciences, in our Indian institutions, women are in positions of power, women are higher up, they are there. And they leave the house, they have the same children after their marriage, and they don't have problems continuing a career which requires them to be out of the house at odd times. So there is something about the bias which is, that's the cultural point that I'm trying to make, that when it comes to a mother-in-law and when it is a daughter-in-law who is a doctor, medical doctor, yes, you should go. That's the way that's your responsibility. But that for a woman scientist, it's equally important to keep those deadlines, to go to that work or to go to that conference is actually going to make a difference whether she can pursue that particular topic to the depth or not. This is a cultural mindset. And how to change that? Only way it changes is by talking to people. But to tell you the truth, I went to a school which was the first girls' school in India. Okay? So that English high school. So that was founded in 1895. Okay, so compared to 1895 to today, we have made a lot of progress. Now going to school, nobody takes it twice. So somehow I think it's not impossible to bring about the cultural changes. But the important thing is that everybody has to be aware of it. And it means mainly, I'm sorry to say this, but the men. Because women are aware of it anyway because it comes from within. But it's actually, I will not let the women also off the hook. Very often we also accept that role. We see a mentor, typical mentor, at least in India this happens. I have seen this happen. A typical mentor, there is a couple, both of them are looking for jobs, and the mentor will tell the girl, this has happened in front of me. The man happened to get a very good offer, and then he told her, why don't you go and look for a job in teaching in a college, that would be best. And this is what I meant by saying that at that point, you are so vulnerable. You don't really know whether you can make it to the end. And then somebody says, this really senior person, he knows, he has seen a lot, and if he tells me that I should go and just teach, perhaps that is what I am fit for. And from personal experience, I can tell you that this was the advice that was given to me. that, you know, you have done well, now you have done your PhD, why don't you go and try to teach in a college? So I think it's also the women who have to realize that they cannot take that as an answer. So it's a cultural change on both fronts, in fact.
Yeah.
I'm interested in what you might think about this. I see saying the family thing is really important, and I would say that that's probably as well, if that can be promoted across the board to both men and women, that would help women as well. Because this idea that a man should have to stay at work and the woman should be the one that, well, if we also provide the ability to allow better leave conditions and stuff for the male, then they go, you know, then it's an acceptance that actually the female should be able to stay at work.
No, as a matter of fact, I'm glad, I'm really glad you said it, because normally I make a slide which I forgot to do today, is that I think that all the policy changes we make should be gender neutral. I mean, that's why I said young couples, you know. I didn't say hiring young women. I mean, the policy should be for the couples. And the same way, I completely agree with you that it should be then the couple's decision as to who would take that short break or how would they share the break. So a realization, as you correctly said, that again goes to the cultural thing, that it is not just the woman's duty. I mean, bearing a child is a woman's responsibility. Nobody else can do it. But rearing, everybody can do it. No, I agree with you completely. I mean,
because what often happens is, like, oh, you know, we've got to do something. Oh, well, I've got to stay at work, and the other person. Whereas actually, it should be, you know, just as easy for me to take the time off and
absolutely
and take that job.
Absolutely. I mean, gender neutrality in all the measures will again go a long way. Because it will increase the acceptance of this neutrality.
Exactly.
See, because it doesn't have to be a break for children. Sometimes you might need to take a break to take care of your old elderly mother, or you may just want to take a break. It doesn't matter. If you can make a gender neutral process where you say that if you take a break, we will help you to manage that break. We will support you. Actually, one of the things that I'm really promoting right now, and I don't know if it will work, is that postdoctoral fellowships which are flexible. See, because the biggest drop comes when you are going from postdoctoral position to a faculty position. Because that is when you have to have the child. I mean, the body clock is ticking. And then you finally, once you have had to take a break, go and have a child, you are left, your postdoctoral position is over, you haven't written a paper for the last 9 months or 12 months, who will give you a job? So, I mean, in the UK, there are these ideas, which again I like, where one says that one should look at not at the physical age of a person while giving a job, but at the scientific age of a person. So if you are hiring somebody, look at how many years of research after PhD, and then is the research output commensurate with the number of years that are spent. So the UK, this has become apparently a actual accepted written rule, which is quite nice. But I think the next is second and better, in my opinion, is the gender neutral measures. So I completely agree with you on that.